All right, welcome everybody. My name is Sean Meckley. I'm with the Amazon Route 53 team. With me is Vahram Sukyas from Warner Brothers Entertainment. This is DNS Demystified, the intro to DNS for Amazon Web Services. Just a quick show of hands to kind of level set. How many folks in the room are familiar with Route 53? Wow, awesome. How many have used a different DNS provider but not Route 53? Cool. How many have never touched DNS? One guy, nice. And how many are in the wrong session? Great. All right, so this goal of this session is to really just give you the real basics of what you need to know to get up and running with DNS for your first application in AWS. And so if you have your applications already running, great, maybe a primer or refresher on some topics, talk about some features that you may not have known about, but really to get you to that basic level of functional with DNS for AWS. So we'll start the session with hopefully under 5-minute discussion of what is DNS. So at a high level, how it works, how it connects your users or your clients to your servers and to your applications. Again, what you need to know without going overboard. We'll talk then step by step of what you need to do to get DNS working to connect a user to your first application in AWS. We'll talk a bit about some of the advanced features that AWS or Route 53 offers to improve the performance and availability of your applications in AWS using DNS. And then I'll hand it over to Vahram, who will talk about Warner Brothers Entertainment's migration of very many domains over to Route 53 for DNS. So first, what is DNS in under 5 minutes? So let's say that you've launched your first web server and you want to serve a website using this server. Your server, if it's connected to the internet, will have an IP address. Let's say it's 1.2.3.4. The IP address is what is used for any type of client, whether it's a human's laptop's web browser or another server somewhere on the internet. It's going to use the IP address to actually connect and talk to this web server. However, humans don't really like numbers. They prefer names. Easier to memorize, easier to type in. And so let's say that you want to serve a website that has a human-readable address. Let's call it www.example.com. Well, you need something to translate www.example.com into an IP address so that the browser or other client can connect to this. That's where DNS comes into the picture. So let's say that you're hosting your website, your web server in AWS. You've got an EC2 instance, and it's got an IP address. Now you have a user with a computer, and they want to go to www.example.com. There needs to be some type of lookup here. So enter DNS. DNS is basically a phone book for the internet. It changes names into IP addresses so computers can talk to each other. DNS isn't just one server, it's not just one system, it's actually a very large distributed system with servers all across the internet belonging to different entities. They all talk to each other. And there's no single source of truth. All of this lookup information, this phone book, is actually a very distributed system. And any one server, any one piece of the DNS system only knows a little piece. It only knows kind of what it's responsible for, and then it knows pointers to other parts of the system which are responsible for other bits. So this domain name is actually going to get broken up into pieces. And you'll see how different parts of that domain name are known about by different parts of the DNS system. So first, the client is going to talk to a DNS server nearby. It's a special server called a resolver. And that resolver is typically run by that user's internet service provider. So when you sign up for any internet service, automatically you'll be configured to use the nearest resolver. And the resolver's job is to take queries, so for example, where is example.com, and translate that into answers. And the resolver does all the legwork of looking up different parts of that name to get a complete answer, and then returns that to the client. So the first thing it does is ask the root name server. The root name server, it's actually a set of name servers, only know about the last part of that domain name, so .com, .net, .org, .uk, and so on. And it will return a pointer to the next part of the chain. So the root name server will get asked, where is www.example.com? And it will reply, I don't know about www.example.com, but I do know about .com. That's my job. And so what it returns is a reference to another name server. And this other name server then knows about .com. So the resolver takes that bit of information and then asks the same question to the name server for .com. Where is www.example.com? The name server for .com doesn't know about www.example.com, but it does know about example.com. So it returns a response saying, I know who knows about what you're looking for. It's actually Route 53. So go ask Route 53, who is the name server for example.com. Okay. But wait a second. How does the name server for .com know that Route 53 is the DNS provider for example.com? Well, actually, if you registered that domain name, you told .com about your DNS provider. It may have happened without you knowing about it, but when you register a domain name, one of the most important things your registrar does is update that name server for the top-level domain, so .com if it's a .com domain name, with information about who your DNS provider is. You can change that information if you want to switch DNS providers at some point. So now the DNS resolver has information about Route 53 knowing about this domain name. So it asks the same question to Route 53. It says, where is www.example.com? Route 53 actually knows. It gives back an IP address. It's www.example.com is at the following IP address. Now, how does Route 53 know? Well, when you've chosen Route 53 as your DNS provider, you create something inside of Route 53, a resource called a hosted zone. A hosted zone is like a container for all of the individual records or entries for things in that domain name, www.example.com, foo.example.com, bar.example.com, and so on. And you create these individual DNS records inside that hosted zone. So now the resolver has a complete answer. It says back to the client, it says here's the IP address. The client then uses that IP address to connect over HTTP or whatever appropriate protocol to your server, and you have a successful web transaction. Now, all of this happens behind the scenes for basically any type of website lookup or any client-to-server communication across the internet. There's generally a DNS lookup followed by the actual connection to the server that you want to talk to. This all happens generally without the user's knowledge. The web browser, in this case, is what's doing all of these transactions. Okay. So that's DNS in a nutshell. You can run your own DNS server. Many people or customers do it. However, a managed service like Route 53 provides several key advantages. First, Route 53 doesn't just run out of one location or one server. We have an anycast network, which means that we have over 50 locations around the world, generally going to be some very close to your end users, which provide a high degree of redundancy and also provides higher performance because those DNS queries don't have to go halfway around the world to be answered. They'll be answered by a location that's quite close to your end user. Because we have redundant locations as well as many other layers of redundancy, we're able to provide 100% SLA on returning answers to DNS queries, which is obviously very important because you need that DNS lookup to succeed in order for someone to reach your website. You can also do some advanced routing using DNS. For example, based on the end user's location, you can give them a different IP address. So you can route an end user to a location. If you're running in multiple regions, you could route that user to a region that's closest to them, for example. You can also have Route 53 monitor each of your locations or each of your servers. And if one of those servers were to go down or become unreachable, Route 53 can automatically respond by giving out a different IP address of a backup location. So you can route your users around failed locations. Route 53 provides some integrations with AWS services that makes it easier to route traffic to things like elastic load balancing, CloudFront distributions, S3 website, elastic beanstalk environments as well. We'll talk about that later. And lastly, it's easy to manage. You can use the web console, but there's also full support of managing anything in Route 53 via the API, command line tools, SDKs, as well as a robust set of third-party tools. So now let's look at the steps involved in creating and setting up DNS for your first website or web application. Okay. So here's our diagram. We're going to do 4 steps. First, you need a domain name, so we'll register a domain name. Next, in Route 53's DNS interface, you're going to create something called a hosted zone. In that hosted zone, you're going to create several DNS records that will point traffic to specific IP addresses or specific resources in AWS. And then lastly, we'll connect the domain name to the hosted zone. This is a very important step called delegation, where you basically update your registrar with the correct name servers for your Route 53 hosted zone. This is what connects everything and makes everything work. The first step is going to be registering a domain name. Now, Route 53 actually provides a domain name registrar within the Route 53 console and API. So you can register new domain names directly in Route 53. We'll show a brief overview of how to do that. You can also register a domain name somewhere else. There's many well-known registrars that you can use, and you can then connect those to Route 53. We'll show both techniques. So first, this is the Route 53 management console. You log in, go to Route 53, and one of the things you see right there on the front page is a search box, just like at any other registrar, where you can search for domain names. So here we'll search for example.com. Okay. Obviously, in the real world, example.com is taken, but for the sake of this presentation, we'll assume that it's available. So we'll buy the domain name example.com, add it to your shopping cart. You can register for multiple years, up to 10 years. We'll also automatically renew. Enter your contact information for the registration. You can hide most of your contact details for most top-level domains, which helps eliminate spam against your contact info. And you complete the purchase, and then we're done. When you've registered a new domain name in Route 53, we'll automatically create the matching hosted zone for you and do that delegation piece, so you don't have to worry about it. Okay. However, if you register a domain name through an existing or other registrar, or let's say you already own a domain name through some other registrar, you're going to have to eventually update some information at the other registrar. Specifically, something called name servers. So if you've already registered a domain name with a different registrar, you're not yet using Route 53, chances are that you're getting free DNS service from that registrar. So here you'll see, this is the other registrar's web console. You'll see some listings under name servers. We'll come back to this in a bit, and we're going to actually update this section with your Route 53 name servers. So that's domain name registration, either through Route 53 or through another registrar. Now let's create the hosted zone. Again, if you've already registered a domain name in Route 53, we've created this hosted zone for you. However, you'll need to create one if you've registered to a different registrar. So we'll look at the hosted zone. You go to the hosted zones tab in Route 53, see example.com listed, you click on the name, and now we're in the hosted zone. You see that there's already 2 DNS records created in this hosted zone for you automatically. These are the default records in every hosted zone. The one that we're most concerned about is the top one of type NS, or name server. And you'll see that there's 4 entries here. These 4 entries are the 4 specific name servers for this hosted zone in Route 53. Now, every hosted zone, by default, gets a unique set of these 4 name servers. So it is very important when you're using Route 53 to enter these exact values for whatever hosted zone you have at your registrar. Okay. So now, let's assume that we've registered the domain name through Route 53 as well. Go to your Registered Domains tab. You'll see your domain name. You click through, and you see now some name servers listed for your domain name. Since you registered this domain name in Route 53, we've already connected everything for you. And so those name server names match exactly. This is what you want. This means that Route 53's DNS service will be serving DNS traffic for this domain name. Okay. Now, if you've registered the domain name through a different registrar, you're going to need to create a hosted zone. So you go to the Hosted Zones tab, click Create Hosted Zone, enter the domain name. This has to obviously exactly match the domain name that you own. You can create a comment if you want. And then you're going to leave the type drop-down to its default setting of public hosted zone. Okay. So now you'll see some records in this hosted zone. Again, the NS record is the one that is most important to look at for now. You'll see 4 name servers listed. Again, these are going to be unique to this hosted zone. Now that we're in your Route 53 hosted zone, we're going to create some records that actually direct traffic to your web server. Now you can create records for your domain name itself, so example.com, we call that the root domain, as well as names inside or sort of children of that domain. So for example, you can create www.example.com, mysite.example.com, foo.bar.example.com, and so on. These are called subdomains. Lastly, you can create records that match any other name that someone might enter into their web browser that would be a subdomain that you don't have an explicit record for. And so these are called wildcard records. Okay, so we'll create all of these and show what that looks like. Okay. So looking at your hosted zone, you click Create Record Set. Now you're presented with a dialog that gives you a couple options here. The first is the name field. Now we're going to create a record for example.com first. So we've already filled in the example.com part because that's your hosted zone. So you don't actually need to type anything into that text box at the top. Down below in the value field, you're going to enter the IP address of your web server and click Create. And now you see the record listed. Now let's create the same thing for www.example.com. So here in the name field, you're going to enter your subdomain, which is www. In the value, you can enter the same IP address, or if it's going to a different web server, you could enter a different IP address. If you want multiple domain names or subdomains to be served by the same IP address, there's actually several other options you can use here. We'll talk about those in a minute, where you don't have to enter the same IP address over and over again. So we'll do that. We'll take one of these other options, something called a CNAME. We're going to create our wildcard record. So the symbol for wildcard is a star or asterisk. So we'll create the record star.example.com. And the type, we're going to change that from the default, and we're going to select something called a CNAME. A CNAME means you're not going to give an IP address. Instead, you're going to give another name, another DNS name. And when that DNS lookup happens, the user is ultimately going to get the IP address belonging to that other name. So here, we're going to enter as the value for the CNAME record, example.com. And what this means is that when a user makes a query for something that's answered by this record, they're going to get the IP address back for example.com. Okay. Click Save, and now we have 3 records created in our hosted zone, in addition to the default 2. Now, there's another option that's important to think about for Route 53, which is if you're creating a domain name or DNS name that you want to point to something like an Elastic Load Balancing, load balancer, Elastic Beanstalk environment, S3 website bucket, or CloudFront distribution, all of those things have IP addresses that can change. And so you don't want to hard code the IP address for those resources. Also, you can't create a CNAME at the root domain. So for example.com, that name itself can't have a CNAME record. Having a CNAME record at that point in your hosted zone actually breaks DNS lookups, and so it's not allowed. Instead, there's a feature called alias. Alias tells Route 53 to go fetch the current IP address for whatever resource you've aliased to and give that back as a response. So what we're going to do here is create an alias record, and you can create that alias record and point that to your Elastic Load Balancer or any of those other resources I've mentioned. Route 53 will always fetch in real time the correct set of IP addresses for those resources. So to create an alias record, you're going to select the radio button for alias, and you'll be presented with a drop-down list where you can select all of your resources, and you can select which resource you want to alias to. You can also then alias to other DNS records in that same hosted zone if you want. Okay. So again, the services that Route 53 currently integrates with for alias functionality are the following. For the last 2, CloudFront and S3 website, there is another consideration here, which is that you need to configure your resources in those services to look for that same domain name. In other words, your CloudFront distribution, you need to create something called an alternate domain name that exactly matches your domain name. And the S3 website bucket, if you're going to use that, the S3 bucket name actually also has to exactly match the DNS name. So if I want to create an S3 website bucket for www.example.com, when I create the S3 website bucket, I have to call that bucket www.example.com. Other types of records that you'll likely want to create in your hosted zone would be, for example, an MX record. An MX record is for email. If you want to receive email at this domain name, your email service provider will give you all the information you need to create that MX record. MX stands for Mail Exchanger. TXT is a text record. You can store arbitrary bits of text in those records, typically used for things like validating that you have, or that you're the authorized sender for email from that domain name. also used for setting up web analytics in many cases for your website. It's also a common way for vendors of SSL certificates to verify that you actually own that domain name. They'll give you a text string, tell you to create the following text record in that hosted zone. When you create that, then your certificate vendor will know that you actually own and control that domain name. Okay. So now we've created your hosted zone, put all the records in there that you need. Next step is to delegate, which means to connect your domain name to Route 53 so that Route 53 starts serving DNS traffic for that domain. Okay. Now, if you've used Route 53 as your registrar, we've already done that for you. We've already created the hosted zone and domain name and delegated between them. Again, the name server addresses are going to be listed for your hosted zone in that NS record in your hosted zone. Okay. The 4 name servers, the term for that set of 4 is called a delegation set. Again, that delegation set is going to be unique to you as a customer. No other customer's hosted zone will share that same set of 4 name servers. This carries some benefits. For example, if there were to be some type of issue with another customer's hosted zone, you're isolated from that because will have at least 2, in many cases 3 or 4 different name server addresses from that affected customer. So every customer is isolated across name server addresses. Also makes it very important that you copy and paste the exact name server names for your hosted zone. Okay. So now, again, this is the Route 53 registrar interface. We'll already populate this for you in the name servers section with your name servers. If you're with a different registrar, you're going to go to that other registrar's web console, go to the name servers section, and replace what's already in there with your delegation set, your 4 Route 53 name servers. Okay. And now you're done. You've made all the entries that you need to do for Route 53 to start serving traffic for your website. However, if you're already using a different DNS provider, that change can take up to 2 days, 48 hours, to become fully effective. And the reason is that these name server entries are cached or saved for periods of time across the DNS network around the world, and those are typically cached with time to live of 48 hours, which means that they'll need to expire before Route 53 is fully serving all of your traffic. Okay. So to recap, we've done 4 things. We've got a domain name, created a hosted zone, created records in the hosted zone, and then we delegated to it. Now, there are some tools that you can use to verify that you've got everything set up correctly. The most popular tools are dig in the Linux environment and NSLOOKUP in the Windows environment. We'll look at dig here. NSLOOKUP functions in a very similar way. So here we have our Linux prompt. Going to type dig example.com, and this is the response that you get back. So there's a lot of information here. The thing we're looking for is in the answer section. That example.com was answered with an A record and with the following IP address. So we see that we were able to get an IP address back for example.com. Okay. Another useful query to do via this dig tool is to make sure that you have the right name servers configured. So here you do dig NS, uppercase, example.com. And here we're not getting back an IP address, we're getting a list of the name servers active for example.com. Here you can see the Route 53 name servers shown. Another useful option is to skip all of the cached or saved DNS responses and make a query directly to each of those name servers that we showed in that diagram, starting with the root name server, then the name server for your top-level domain, and then Route 53, and so on. You do this by doing dig, then the domain name, and then with the option plus trace. The response is going to be very verbose. It's going to scroll off your screen, but we've condensed it a bit here to show each of the different queries that happened. First was a query against your root name server. That's that top row. That gave back an answer for .com. Query against that name server then gave back an example, or the response for example.com. And finally, the query against Route 53 gave back the IP address, which is shown as 175.41.145.117. All right, so that's basic DNS. Now you have DNS working for your first website. We'll talk a bit about some of the advanced features you can look at in Route 53 as you grow your application. First is when you move from a single server to multiple servers serving your application. Let's say that you're within a VPC, or virtual private cloud. It's not just users, humans, that want to use DNS. In very many cases for machine-to-machine communication, DNS is also going to be involved. So for example, if a server wants to connect to a database, typically there will be a DNS lookup involved. For DNS within your VPC, you can create something called a private DNS hosted zone. This allows you to create DNS records for all the internal pieces of your architecture. And it has several advantages over public DNS. One is you can use any domain name you want. You don't actually have to own the domain name. So I could call this my domain name Sean.internal, for example, without actually having to own that. Next is private DNS is only visible inside your VPC. So users on the public internet can't find out the IP addresses of the pieces of your application, and they also can't find out the names. So you're able to hide your topology of your network or architecture as well as the actual IP addresses. Another useful feature for public DNS is health checks and failover. So this allows you to set up things like a backup web server in case your primary web server were to become unreachable. Route 53 can provide a health check for you of that primary web server. And if that shows that your primary web server is no longer reachable, Route 53 will automatically stop giving out the IP address of that primary server and instead give the IP address of your backup web server. You can also run multiple active servers at the same time, each with a health check. And if any of those servers were to go down or become unreachable, Route 53 would simply remove those from the response it gives to users. You can use several different routing techniques for multi-region applications. So let's say you want to run in multiple AWS regions to get closer to each of your end users around the world. Route 53 offers a couple of different routing techniques to route based on either the fastest internet connection between your user's location and the region, or by geography. So you can do geographic restrictions, say all users from countries X, Y, and Z must go to this region, or some combination of those different routing logics. And lastly, if you want to get very sophisticated and have multiple levels of routing decisions, so by continent, and then also by internet latency, and then also, let's say, with failover between different regions, you can combine all of these using a tool called Traffic Flow. Traffic Flow gives you an intuitive web console-based sort of flow chart. You can build out these routing decisions with each of the different rules, geography, round-robin distribution, failover, and so on, that ultimately would lead to a given end user being routed to one of the multiple servers or multiple locations. These traffic flow charts are then called a policy, and that policy is also represented in text format. You can export that, version control it. You can also then roll back to previous versions if you want. It's a very nice way to manage sophisticated routing without having to edit a whole bunch of individual DNS records. For traffic flow, we have a session coming up tomorrow. I encourage you to visit that session if you want to learn more about it. Now I'm going to hand it over to Vahram, who will talk about Warner Brothers Entertainment's migration to Route 53.
Thank you, Sean. Thanks for having me. Hello, everyone. My name is Vahram Sukyas. I'm the VP of Application Infrastructure and Operations, thank you, over at Warner Brothers. Quick show of hands. How many of you are considering migrating your public DNS to Route 53? Okay, so I have some particularly useful information for you, which I hope will save you some time. If you're not considering it, I hope I still have some good info for you. Should be able to wrap up ahead of schedule, so if you have questions at the end, feel free to line up at the microphone. Happy to take them. So before I get into our migration tale, our story of how we moved all of our public DNS traffic to Route 53, I'd like to set some context first. So I'll talk a little bit about Warner Brothers, who we are, valuable context, how we use AWS and how we've used it over the years, what our DNS setup looked like prior to moving to Route 53, the road we took to Route 53, no pun intended, our results, and what's next for us. So who are we? We are a global leader in the creation, production, distribution, licensing, and marketing of all forms of entertainment. Now, most of you, I'm sure, know us for movies and TV shows. We also have big gaming divisions. So for you gamers, I'm sure you've played several of our titles before. But that's who we are. Now, I put the word global in bold and italics for a very important reason. I'll cover that in a second. But with all of these divisions that produce all this content and entertainment comes a lot of applications and a lot of domain names to the tune of over 25,000, which I'll talk about a little bit more in a bit. So how have we used AWS in the past? We actually have a long history with AWS. We have some divisions that have been using AWS for many years, most notably brands such as TMZ and their main website, tmz.com, Drama Fever, one of our gaming studios, Turbine, and others. But there are some units, some groups such as ours that are in the process as we speak of migrating our applications to the public cloud, namely AWS. So the primary drivers, and this is speaking across my interactions with different people at the studio, the primary reasons for moving to the cloud is the four that are in the middle of the screen there. So application isolation and billing clarity go hand in hand. A very common pattern across WB is a group stands up a data center. They start pouring a few hundred applications into the data center. They're all sitting on maybe, I don't know how many VLANs, maybe 1, maybe 10. But ultimately, over time, what happens is you lose the true cost of ownership of an application. So we take what I'll call, quote unquote, micro data center strategy. We stand up these little virtual micro data centers in the cloud. We have over 150 as we speak. And those accounts map loosely to an application. Sometimes it's an environment of an application. Sometimes it's a group of similar applications. But point being, we're now further isolated, which gives you a security benefit. If something happens to one application, the odds of it impacting another one in another account, that's now gone, right? So security comes hand in hand, not to mention the automation and security features that come to AWS. But that's not what this talk is about. Agility is the other one. I'm sure you all love spinning up VMs and having it come up in 2 minutes. That's also a big factor for us. We enjoy that as well. So what did our setup look like before moving to Route 53? It was an on-premise solution. Well, on-premise is a little bit of an incorrect term there. We had 2 VMs running in AWS, one in East, one in West, 1 VM running in a data center, and those were 3 name servers. Running by 9, no self-service. So my group manages most of the domains across the studio, like I said, over 25,000 of them. That means that if someone wanted to do some kind of maintenance at 2 a.m. on a Saturday, it's a ticket that comes into my group. Someone has to wake up at 2 a.m., take care of them, resolve the ticket, off we go. Not the most friction-free way of doing things. So self-service is an important consideration for us. With these 3 VMs also comes poor fault tolerance. Our 3 VMs are far less than the points of presence that are available on Route 53. And we all saw what happened a month ago with that big DNS outage, right? So if that could get overpowered, imagine what you could do to 3 VMs. Poor geographic distribution. Like I said, 1 in the East Coast, 2 on the West Coast. That means that international lookups suffer. We are a global company, as I said earlier. So why should the experience from Europe or Asia or anywhere else suffer because we're not properly geographically distributed? It's a very often overlooked component of application performance. If you could get DNS performance increased, your application will respond quicker. It's just easy win. 25,000 plus domains, that was the scope of what we had to migrate. Some zones were quite big. WarnerBros.com has over 10,000 records within that zone file. But ultimately, the takeaway for any of you that are running an on-premise DNS solution, whether it's Bind or TinyDNS or whatever you have out there, Microsoft DNS. Ultimately, the one takeaway, and I'm a big believer in this, is if you operate DNS without an API in front of it, it's pure misery. And that's one of the things that we, of course, got as part of our migration to Route 53. So prior to doing the move, we had a few things to consider. One was the domain registration process. When you have 25,000 domains, you're going to be registering domains pretty frequently, and that process had to continue running smoothly. We also had to devise a scheme for reusable and hopefully WB-branded delegation sets. Then we had to find a way to import and validate thousands of zones. And mind you, we did a lot of this work behind the scenes. We did notify some groups, of course, but at least to the average WB employee, this was happening very much behind the scenes. If we missed one record during the import process and an application went down because of it, that's a big problem. So we were shooting for 100% accuracy. Anything less than that is a failure. Then we also had to verify that IAM and zone delegation works exactly as advertised, because what would be the point of moving to Route 53 and then not be able to give someone self-service to manage their own zone? Kind of defeat the purpose, so we had to check that box. And then we had to worry about raising several Route 53 default limits. So this is a screenshot taken maybe a month or two ago. I don't know if anything has changed, but of the default limits that you get with Route 53. So we spun up an AWS account. That's where all of our zones are going to go into. And then we proceeded to raise limits. So 500 zones per account, that's obviously way too low for us. We got that raised. Reusable delegation sets. I'll talk about the importance of why that is in a second, but we bumped that limit to 2,000, which I believe is the highest it goes.
That's for hosted zones per delegation set, yep.
And then we had to bump the resource record set limit. Like I said, we had some zones that had 15,000 records within them. So we're now done. Our limit for delegation sets is 2,000. That means we can migrate zones in chunks of 2,000 domains. So imagine having to work with your registrar and telling them we want to cut over this many domains, right? The bigger that list is, the easier it is for us. And our goal was to finish this project in roughly 6 weeks. Pretty short time frame, considering that volume of domains. So the bigger that limit was, the more chunks, the more domains we could fit in the chunk, less work we have to do with the registrar, speeds things up. So in order to fit in that 6-week time frame, we're talking 2 to 3 batches of 2,000 domains per week. Very next step, we had to write a tool to validate those zones as we transfer them to Route 53 to ensure for that 100% accuracy, so we did that. And then we wrote a tool to easily set up new domains. So if you're the person in charge of acquiring domains for WB, and you have to guess which delegation set isn't exceeded, kind of hard, right? So we abstracted that logic. Now they could go in, register the domain. It automatically creates the zone file within Route 53, and it assigns it to a delegation set that's available. Then we had to lower TTLs. So this is a failsafe. We lowered it on the bind side, then imported it into Route 53. If something were to go wrong for whatever reason, the time to cut back would be shorter while we figured out what happened. Luckily, we didn't need to do this. So then we picked up the phone and gave Sean and his team a call. And we talked about what the right way was to do this. And they recommended an open source tool called CLI 53. It worked for the most part. And this is what I mean by the most part. So what you're looking at here is a pull request that is now thankfully merged into the project. So this is actually a documentation fix, believe it or not. In Route 53, when you create a zone, there's a name with the zone, and then there's a zone ID. Doing lookups by zone ID is quicker. And when you're trying to import 2,000 domains at a time, it slows down drastically if you try to do things by name. If you have to delete the zone, it slows it down. So we couldn't even tactically accomplish those chunks of 2,000 by passing in names to CLI 53. Now, it turns out that this wasn't a big deal because the code had the concept of zone IDs, but the documentation didn't state so. So the pull request literally changes the argument flag to say, hey, you could pass a name or you could pass an ID. Great, now we're good. The second issue we found. For the most part, zone IDs are 12 characters. So we got through, I don't know how many thousands of zones that we imported successfully, and then boom, hit a bug. It would not import. Why? The zone ID was 11 characters. I believe it could also be shorter than that. So technically this isn't 100% accurate, but this enabled us to complete the project. We didn't hit that bug again. So simple fix to a regular expression to shorten the character length enforcement of a zone ID. So hopefully that doesn't happen to anyone else here. Hopefully we paved the road for you guys, but that's what those two fixes were. So what were our results? 25,000 zones, got it done in under 6 weeks. Pretty impressive. The big takeaway was that upfront investment in automation made all the difference in the world. To my knowledge, no one picked up the phone and said my application is down because some record didn't come in. So as far as I'm concerned, it was a slam dunk, 100% error-free. And now, of course, we have the benefit of allowing people to self-service on their zones. Big win. Everyone's happy and excited. Of course, we also gained the soft benefit of that greatly reduced risk of a DDoS attack, taking down DNS. Like I said earlier, I'm sure Amazon's network is considerably more capable of taking that on than our 3 VMs were. And last but not least, increased performance that I alluded to earlier. So this is a map of what it looked like before. This is using a synthetic monitoring tool that my group uses called Catchpoint. It's a geographic map of DNS latency around the globe. So what this is literally doing is doing, like in Sean's example earlier, a dig against what was ns.warnerbros.com, I believe, and then recording the latency. So green is close to 0, makes sense, right? West Coast has some good numbers. East Coast, a little bit better, a little bit worse, sorry. Going out to Europe and Asia, awful. At the end of the day, it's speed of light. You're not going to solve that by simply being in the East Coast. And this is afterwards. You can see our European customers are now a lot happier, a lot more green there. Some red in China, India. So I was actually talking to Sean about this earlier. This is going against one of the name servers that is associated with a domain. Behind the scenes, that gets sharded out to multiple locations. So if the test were to occur across all 4 name servers, that would get flattened out. Unfortunately, couldn't do that in the tool. But overall, lesson learned, moral of the story, performance got significantly better around the globe. And here's a screenshot of what it looks like. These are our branded delegation sets. So this is a DNS lookup for NS records against warnerbros.com. And you can see it's branded with a WB name. NS1 through 4 is just standard convention. And then the part after the hyphen, that's how we cycle through delegation sets. So A to Z, 1 to 9, and that gives us plenty of headroom. You know, at 2,000 per delegation set, we could fit an eternity worth of domains, I'm sure. So what are our next steps? While we have self-service at the zone level, what we don't have today is self-service at the individual resource record level. warnerbros.com, as I said earlier, 15,000 individual resource records underneath it. Different groups control those individual resource records or should have ownership over those resource records. We don't have that fine-grained level of allocation to those groups. So something we're looking forward to solving in 2017. Hopefully they beat us to the punch. We'll find out. Have a little race. And then, of course, we also want to start leveraging the advanced traffic policies and health checks that Sean spoke of earlier. Lots of benefits to doing that we simply didn't have in the bind world. And last but not least, we're certainly not a 2-year-old startup. It's amazing how much cruft builds up in DNS over time. And I've never seen that before, not having worked at a company that's been around for as long as Warner Bros. Before in my past, but lots of cleanup to do. Unfortunately, you know, groups oftentimes will retire an application. They'll forget about retiring DNS. It stays in DNS forever. What that means downstream is paying more for zones that are no longer needed, slower API responses because your zone has 15,000 records underneath it, whereas if it had 5 or 10, things are faster. So it's a good hygiene measure that we'll be taking in 2017 as well. And with that, thank you very much. If you have any questions, feel free to step up to the mic.